Welcome back, friends. Let us try to solve one more problem on non-concurrent force system. It is from question paper July 2019, asked for 8 marks. And by looking at the figure, we can say it is very simple if you know the concept. So the statement goes like this: determine the resultant of force system acting on a body as shown in figure with respect to point O. All the time they used to give the point about which we supposed to locate the resultant. Here they have again stated that we need to locate the resultant with respect to point O. So as the figure given here is, this is something like this. This is our point O. This point is O, and here we have vertical force of 300 and right side acting force of 400 Newton. At a distance of from O vertically up 3 meter towards left 0.5 meter. At this point we have an inclined force of 500 Newton, for which they have given a slope 3:4, 3 vertical 4 horizontal. And from this point again at a height of 3 meter, or we can say from point O about 6 meter towards right at 1 meter, we are again we have an inclined force of 200 Newton, which is making an angle 60 degree with respect to x-axis. I have made here a free body diagram and try to represent a forces which are vertical and horizontal. This is 300 and this is 400 as shown as it is, because there is no need to resolve the force. First we resolve the force which is acting at top at a distance of 1 meter from O. It is 200 Newton, as the angle given is 60 degree with respect to x. So it is something like this. This force is in fourth quadrant, making an angle 60 degree with respect to x. When I bring it along x, it is acting towards right. So here we will show a force acting towards right, which is of 200 into cos of 60. 200 cos 60. Then a vertical down, it is 200 sine 60. Now at this point again we have a force of 500 Newton. Again it is inclined, we need to resolve it, but for which they have given a slope. So I have worked out it. We'll take this triangle here. I have enlarged this triangle here, which is 3 vertical 4 horizontal. If I take with respect to x, this as theta, so tan theta is equal to opposite side by base, where theta is 36.86. If this angle is theta with respect to x, along this plane it will make an angle theta with respect to x. So we can take this angle as theta now, 36.86. Now look at here, it is in third quadrant. When I bring it along x, it is acting towards left. So left acting force of 500 cos of 36.86. Similarly, when I bring the same force along vertical, it is acting downward. So downward acting force of 500 sine 36.86. I resolve the force now. All the forces has been resolved. Now let us calculate summation of h. To calculate summation of h, our sign convention is right side acting force are positive, left side acting force are negative. This is a sign convention. Now look at the free body diagram, which are the forces acting towards along x direction. So we have 3 number of forces. So let us first write positive forces which are acting towards right. 400 is acting towards right, so plus 200 cos of 60 acting towards right. This 200 is acting, cos 60 is acting towards right, and then this 400 is acting towards right. Whereas this 500 minus 500 cos 36.86 is acting towards left, so it is minus. Now summation of h will go get, I will make use of calcium and work out 400 plus 200 cos 60 minus 500 cos of 36.86. It sounds to be 99.94 Newton it is. Okay, now let us calculate summation of v. To calculate summation of v, our sign convention is upward acting force are positive, down acting force are negative. This is our sign convention. Again look at this figure. 300 Newton is acting upward plus, then whereas 500, this 500 sine 36 acting downward, 500 sine 36.86 is acting downward, so minus now this 200 sine 60 is acting downward, 200 sine 60, this is also acting downward, so it is minus. Now I'll make use of a calci again. Let us try to work out 300 minus 500 sine 36.86 minus 200 sine 60. It's minus 173.13 Newton. Okay, we got summation of h and summation of v. It is very easy to calculate resultant. So r is equal to square root of summation of h square whole square plus summation of v whole square. So r is equal to it's 199.91 Newton. It is a resultant. So similarly we calculate angle made by the resultant. Theta is equal to tan inverse of summation of v divided by summation of h. So theta is equal to 173.13 divided by 99.94. Just okay, while calculating theta we need to take care here. Just consider magnitude of summation of a summation of h. Don't consider sine to calculate an angle. It is 60 degree. 60 degree. Theta is 60. Now as the question asked is locate the resultant with respect to point O. So we need to take moment about O, summation of moment of all the forces about O. We are taking moment of all the forces here about O. This is a point O about we supposed to take a moment. Look at here. This 500 Newton, the line of action, if I project upward, it is passing through O. The moment of this 300 is 0. So I will write here 300 into 0. There is no perpendicular distance because the force, line of action of the force is passing through O. Similarly, this 400 Newton, the line of action of this force is also passing through O. So plus 400 into 0. If you write or doesn't write, doesn't matter because it is 0 already. We need to ignore the forces which make 0 moment. Okay. Now for better understanding, I am showing here. Now look at here. First I will consider the horizontal acting force, which is 500 cos 36.86. It is acting towards left. It is 500 cos 36.86. Okay, now the force is acting towards left. With respect to this force, point O is above or below? It is below. It is below. So if this arrow mark follow this path, it will make clockwise movement. So it is plus 500 cos 36.86 multiplied to the distance. So with respect to this first point, O is downward. So we need to consider downward distance, which is 3 meters. Okay, now then we have vertical force. Vertical force is acting downward. Vertical component 500 sine 36.86 acting downward. With respect to this vertical component, point O is towards right or left. With respect to this, it is towards, look at here, this becomes a line of action. So with respect to line of action, O is towards the right. So towards at the tip, exactly draw a line towards the right. If this arrow mark follow this path, again it is make clockwise movement. So plus 500 sine 36.86 multiplied by the distance from the line of action of the force about O is 0.5. So multiplied by 0.5. Okay. We have taken this taken moment of 300, 400 and these two component. We left with these two. Okay, let's we'll take the horizontal component first. The horizontal component first. The horizontal component is acting towards right. So we'll consider here towards right, which is 200 cos 60 is acting towards the right. With respect to this component, point O is above or below? It is below. Exactly at the tip, draw a line downward. If this arrow mark follow this path, it will make clockwise movement. So plus 200 cos 60 into the distance we need to multiply is from this line of action, from this line about O, so vertical down. So it is 3 plus 3, which is 6. right? Now we have a vertical component which is 200 sine 60 is vertically down. Look at here, the line of action is something goes like this. With respect to the line of action of this force, point O is towards left. Exactly at the tip, draw a line towards left. Draw a line towards left. If this arrow mark follow this path, it will make clockwise movement. So here it is plus 200 sine 60 into the distance we need to multiply is from this line of action about O, it is 1 meter. So it's 1 meter. Now moment about O is equal to, it is, this is 0, leave it, this is also 0, leave it. Then we'll start with 500. 500 500 cos 36.86 plus 500 sin 36.86. 536.86 into 3 plus 500 sine 36.86 into 0.5 plus 200 cos 60 into 6 plus 200 sine 60 into 1. It is 2123.32. It is in Newton. Distance is in meters, so Newton meter.